Hi, I'm Brian Grant. If you don't know who I am, bgrant0607 on GitHub, LinkedIn, Medium, Twitter, Blue Sky. I was part of the team that created Kubernetes, the original architect of Kubernetes. And if you use Customize, that was my brainchild. I've been working in this space for a really long time. I was at Google for 17 years. I was part of the CNCF, the original inaugural CNCF Technical Oversight Committee, bringing projects into the foundation, which is where I first worked with Alexis.
I worked with Brian on the TOC as well. I was the first chair of the TOC for several years, helped to get the CNCF up and running. At the same time, I was the CEO of Weaveworks and founder, where we created GitOps and Flux, but some of you might use Flux. Before that, I was at VMware, around the Spring team at Pivotal, created Spring Boot and Spring Cloud as from a product person's point of view. And I got into that by doing RabbitMQ many years ago, which was acquired by VMware. And long before that, I started my career in finance as a derivatives trader. Oops.
OK. Yeah. So today, we are going to talk about what's possible when the configuration is fully rendered with no templates, no variables, no conditionals, no loops. It's just configuration data. So that is a very different model than you might be used to. So we're going to talk first for a while about what that is and why that would make sense. So to start, imagine a scenario where you have multiple applications running across multiple environments. They're Helm charts, YAML files, other configuration files. Might be spread across multiple repositories. They may be in different directories. They may be organized differently or broken down into files differently. They may use different conventions. So kind of very heterogeneous. Some of them may be in repositories with application code. Some of them may be in repositories with configurations from many, many applications. People do it all different ways, even with a single organization. Often there are multiple different approaches to organizing configuration. So here we just have like a really, really simple example of 3 sample applications. One of them is ours, and 2 of them are just ones I found on GitHub. There's an AI chatbot on the left, and a voting application, and an online store. So they have different numbers of YAML files, and they're broken down in different ways. But actually have these running here, it's a little bit tricky to move the cursor over here, but yeah, they're just running, and there's dev versions and prod versions here. So an individual app team probably understands their configuration to some degree. They know where it is. They know what process they should use to change environment variables. They know where the values files are, whether they have any values overrides, things like that. But if you can imagine other people in the organization that may be responsible for those, operations staff or security people, may not be as familiar with each individual application. And that's where this configuration sprawl can really become a problem. This one.
Another way that you might be thinking about your app is different stages or different regions. And they might need slightly different configurations, and that'll be important later on. Quickly want to thank Artyom Lyko for giving us this diagram to use today. Artyom wrote a wonderful blog post a few days ago about this topic.
Yeah, so what do you do when an urgent update is required? So let's say there's a bug in a new feature, or some operational issue, or some security issue that needs to be addressed really urgently. It could be like a recurring container room, or a bug in a new feature that you want to disable, or a security issue that you want to address right away. And over again, even to today, very sophisticated platform teams still tell me that they break glass and just go change the state in the cluster directly.
One of the things I learned from doing GitOps, I would talk to customers and say, what do you not like about GitOps? And one thing they complained about is operations folks find it hard to use. They don't want to learn dev tools. There's too much YAML. I don't want to understand Terraform. You're making me do too many things. Also, when there's a problem, I want to fix it quickly. I don't want to hunt the needle in the haystack around different files, different places. It's very, very upsetting and confusing. So can you give me something better and faster to do?
Yeah, so if you want to update the configuration in Git, the first thing you need to do is find where it is. If you don't already know, like I said, if you're not on the application team, you may not actually know. So Helm adds some annotations to all the resources that get deployed, but they actually just give you information about what is the Helm chart, what is the Helm release. They don't actually tell you, for example, where are the values. I think an underappreciated benefit of GitOps is that with GitOps tools, usually you can. So for example, Flex adds, I think it's labels to the resources so it can select for those resources, and then it can trace them back to the Flux resources that have the information about where the source comes from, whether it's Git or OCI, and where the values files are. So here you see down here, that it actually says where in the repo, if I can move the pointer when I'm sitting sideways, where the actual values files are in the repo. So that's actually very useful information. So a single command can at least point you in the right direction. But once you find the Helm the templates and the values, then you actually need to make it the right change to, like for example, change the right values to affect the right environments, because maybe you don't want to affect all the environments. Maybe you just want to change the values for one region, for instance. And in simple cases, finding those right values is really easy, but in some cases there are values overlays and values overrides on command lines or in GitOps configurations. Or maybe there's a post-rendering step, or maybe you have multiple tools chained together, for example, Helm and then customize. So then like figuring out which layer you need to change with layers can become pretty complicated. And it can even happen that maybe those values aren't even parameterized. So, like in this example of probe settings, the values could be hard-coded or they might even be unspecified. And then you have to change the template. And if you change the template, that can potentially affect everything that uses that template, all environments, all regions, et cetera. And that's where, people become concerned about blast radius. So people talk about blast radius as the scope of all the different possible, running environments that might be affected by a single change. And that's where people tell me, with kube control, I can just make a change in a few seconds. And if I have to go update the Helm chart or the repo or something, it can take hours or days because they have to do a lot of analysis to figure out if it's safe or not, for instance. So to avoid that problem, some organizations are adopting an approach where they parameterize everything preemptively. So, there was a talk at KubeCon several years ago from someone, Michael Goodness at Ticketmaster, showing this approach. This is an example from the OneChart project. It's literally called OneChart. And the idea is that, if you parameterize everything, you can use it for everything. But, then the Helm chart can become very challenging to understand still. It may be parameterized, but sometimes there's a value for an individual field. In some fields, we'll inject whole snippets of YAML, and you may have to, a simple grep may actually not find the thing you need to change. You have to do a little bit of splunking through the templates to figure that out. So, and if the issue is with an off-the-shelf component, a popular component like Cert Manager or Prometheus or Grafana, those charts are often even more heavily parameterized than charts for people's own applications. This is an excerpt from the Traffic Helm chart, which is a pretty well-maintained Helm chart. The chart has 2,000 lines of templates and another 3,000 lines of default values and value schema. So you can just like page and page and page through it, and and there are parts that have where multiple parts of the values have similar names and things like that. So it can be a little challenging to figure out which are the right ones you actually need to change. We use traffic for ingress, and our use case is relatively simple. For our use case, the values render out to just 300 lines of standard Kubernetes YAML. So it's actually way easier to understand the rendered YAML than the chart, both just due to the size, but also the complexity of all the conditionals and everything that are in the template. Because obviously, most of that just goes away because it's all has conditionals that are, that disable those sections of the YAML. And these Helm charts are installers. They're package installers, they're software installers. So it's not surprising they're more complicated. They need to support every possible scenario that the chart author wants to support for that application, whereas you're just using it for one scenario. So the single scenario is always going to be simpler than the cross product of all the scenarios.
One thing that makes this hard is that if you put things in Git and then choose values for variables, you end up with a sort of tree structure where you have to know exactly the right path of choices to make to get to the leaf of the tree, which corresponds to the thing or things you want to change. And if you get this wrong, you could accidentally blow up something else. What you'd really like to be able to do, on the other hand, is just point at the one thing that's not working and fix it directly. For me, this resembles, I don't know if you remember from computer science, the P equals NP problem. Verifying an answer is much more efficient, pointing at the answer, than trying to figure it out yourself from scratch, especially when the world is ending around you.
Okay, yeah. Yeah, so as I mentioned, a number of people have told me that it's not only simpler and faster, but even safer to just go change the cluster directly. But if you're using a GitOps tool like Flux or Argo CD, if you want to make a change to the cluster, first you have to suspend or disable the GitOps tool. Otherwise, its drift reconciliation will just clobber the thing that you did right away. And then, if you want to make the change permanent, then you have to figure out, how to actually safely and correctly modify the template or the patches or the configuration generation code to actually incorporate your change. And then you have to remember to go re-enable the GitOps reconciliation loop and hope that your configuration change actually didn't change anything in the production environments. So, you could also try to use AI to help you make those kinds of changes, which wasn't an option in the past, but that I found to be not as straightforward as you might think, because not only do you have to tell the AI agent kind of what change you want to make, but you also have to explain a lot of constraints so it doesn't make changes that you don't want it to make. And that can be an iterative process, and it has to be reviewed very carefully. So the difficulty in determining whether a change is correct in a complex configuration has led some people to use the render manifest pattern, where they render all the configurations in advance before deploying them to the cluster, so they don't find out, at the time that a Helm chart hits the GitOps operator, whether the configuration is what they expected it to be or not. And that makes the configuration more straightforward to review and also ready to push through linting tools and policy tools like kubeconform and Kubernetes, for example. So instead of needing to understand both the templates and the structures of your values, like the examples on the left, you can just look at standard Kubernetes YAML and the values in place on the right. So that can increase the confidence in changes, but it doesn't help you make those changes any faster. So, and some people have even told us, which I didn't expect, that rendering the manifest can even slow down the process just because of bottlenecks in CI workers. Like if you have to render the manifest for enough different environments every time you change anything, that can actually be pretty expensive to do, depending on how many environments you have and how many charts you have and so on. So another case that comes up pretty frequently is people have to make changes not just in one template or one application, but actually in a number of different ones, but for similar reasons. For example, if you need to make a change due to a security posture change or something like that, you probably have to make it multiple applications, and those templates are totally different. So even in this simple example with just 3 applications, there are 18 YAML files, right? So if you have to change even a small 18 YAML files with Kubernetes deployments in them. So if you have to change, even a fraction of those, it already becomes enough changes that is error prone to do. And if you have dozens or hundreds, then it can be very painful. So all these formats, mostly I've been using a Helm as an example because that's what most people use. Customize is the second most popular tool. CDK is also pretty popular, but whatever the format is, if it's expressed like code, it could be JSON, or it could be QLang, it could be your favorite programming language, whatever. Those are sometimes called dry formats for don't repeat yourself. They factor out common parts of the configuration in code, and it's a configuration generator that actually generates the final configuration. And plain YAML is sometimes called wet configuration, the opposite of dry, for write every time or write everything twice. And the dry formats are intended to facilitate generation of multiple similar configurations. I mean, if you just had one configuration, you would just write wet configuration because you only need exactly one. But you probably have slightly different variants, for example, for different environments or different regions or for different scenarios. And that's what drives people towards these dry formats. But the complexity of those formats makes understanding configuration more difficult. It makes making changes more difficult than any individual variant, like in the off-the-shelf case. So we believe the solution to that is actually to always just use wet, fully rendered, fully explicit configuration. And that may be counterintuitive because infrastructure as code kinds of approaches has sort of been the de facto best practice for about 30 years. Some people are adopting it only recently, but CF Engine was like 1993, right? So it's been around for a long time. So we're going to talk about using a different approach. We're going to show the approach using ConfigHub, but there are some other tools out there. For example, you could use Porch, which is another project I started, to manage configuration in this fully rendered wet form. And I am going to show you a demo here. I am actually going to try to do it live if the Wi-Fi works.
So we'll be demoing ConfigHub itself here, which is on confighub.com.
Just a second. All right. Where is my cursor? All right, here we are. Okay, so this is ConfigHub. ConfigHub stores the configuration as data. So the configuration data is stored in objects in a database instead of storing configuration generation code in Git. This is the configuration for the 3 applications I showed before, deployed across 2 environments, so 2 clusters, dev and prod. If I expand these things out, you can see, the individual, what we call units of configuration collapsed under there. And if I take a look at these are just standard Kubernetes YAML with no variables, no conditionals, no loops. It's just a pure data representation of these resources. In ConfigHub, there is also a one-to-one correspondence between the configuration in GitHub and the resources in the clusters. So, if you change one resource in ConfigHub, that can only affect one resource in one cluster. So it has a very constrained blast radius. So this is kind of similar to the rendered manifest pattern, but the configuration is always fully rendered. There's no rendering step per se. I need to come back here to click. All right. I can try. Let me. Yep. Okay. So let's revisit those break glass scenarios that I mentioned earlier. To make a change through ConfigHub, the first thing you would need to do if you saw the issue in the cluster is find the corresponding unit. It's a little bit awkward to manipulate things on this other screen, but okay, here we go. Okay, so as with GitOps, I can actually use information annotations on the resources to trace the resource back to its configuration source in ConfigHub. So one disadvantage of this is okay, so here I just, navigated from, what? That's interesting. Oh, I know why it is. The wrong window. I wasn't logged in the other one. That's annoying. All right. Let's try that again. There we go. So if I saw the problem in the cluster and I'm not sure where it is in ConfigHub, I can actually just go straight there, similar to like the flux trace command, for example. So unlike the traditional GitOps, the configuration is just plain Kubernetes YAML, so we can actually change it programmatically. So if the issue was container room, for example, I don't have to change the YAML by hand. I can go here and see, there are some resources, but, maybe there's not enough memory here. So I can actually execute what we call functions to just change that. Okay, so let's see if the Wi-Fi works. Oh, operation. Thank you. Good catch. Yeah, it's hard to see from over here. There we go. Can't blame the Wi-Fi. All right. Yeah, so you see here that it actually automatically changed those. So this is, you can think of these functions as like a simple tool to help you make changes, and it will validate the inputs, make sure that they're proper Kubernetes resource quantities, for example, and that you specified the right things, and it makes the changes in the correct place with the correct indentation, all that, and you don't have to worry about it. You can also, for resources is a pretty common case. So the cases that are, similar that Customize supports built-in transforms for, like setting images or setting replicas, setting resources, things like that, have functions already. You can also write your own. If you need to disable a feature with an environment variable, that's also something that's pretty straightforward. So I can do, if I can type. We also have a CLI too, but the terminal's pretty difficult to interact with. Okay. So here I'm just going to disable this feature. Just going to do dry run so I can run it again if I need to. Okay, yeah, so here you see that the value has changed from true to false. So that reduces a lot of the error proneness of making a lot of these kinds of changes quickly when you're in an emergency scenario. And in the security example, that is a little bit more complex than just changing an environment variable. But if you've decided what best practice values are that should be set in the security context, then you can just encode that in a function and set all those values in one go with a very simple interface. So you see here, I actually set run as non-root to true, for example. And a benefit of that for just changing one instance, it's not too big of a deal, but what if you need to change 50 or 100? I mean, in this example, we have 42 units of configuration, and I actually can change all of them as easily as I can change one. And because these are just data, I can also query. So I actually have a canned query here to search for all the deployments that don't have run as non-root set in the security context, and I can just select all of those and apply the same function. Yeah, so you see here, all of these different units, I was able to perform the same transformation. So, these aren't deployed right away. This is just change the state in ConfigHub, so there's an opportunity to review and validate the configuration before it's deployed. But, making those mass changes can be very challenging to do with these dry formats. With configuration as data, we provide an API to the configuration data, and that enables you to automate the changes to the configuration, either through functions or through tools built on top of ConfigHub. I don't know if I will have time to show validation, but ConfigHub has features similar to dynamic admission control in Kubernetes. So after every single change, you can find out, you can ensure that the configuration is valid. We can run kubeconform on every change, or policies on every change. Right now we have cell policies integrated, but it'd be straightforward for you to integrate Open Policy Agent or Caverno as well. So let me go back to the presentation. Okay, just run through.
So what are the takeaways here? You can see my t-shirt. Config is data. Configuration as data. That's the one thing to think about after this talk. Well, think through the implications of that. What are we doing? We're separating the data part out from the programmatic part. We're not throwing the programmatic part away. That just sits a layer above the data, just like we were taught to do in the 1960s, separating data from programs and having databases instead. This allows us to look after the data properly and do some of the cool operations that Brian showed you, which is going to make your operations a bit easier. You can keep using Kubernetes, Flux, Argo, Helm. Well, Helm, got to be careful. This will make Helm a bit safer. Keep using it as a packaging tool, but don't rely on it as an operational delivery tool. Use values instead. That's the takeaway. And then you're on a journey to, we hope, Ops Nirvana one day. Thank you very much.
I think we have about 1 minute for questions, if you have questions.
Any questions? Oh, this gentleman here.
There's
Jeff.
a microphone over here for...
Do you want to take my mic?
Yeah, I really appreciate this. When you talk about the rendered manifests and getting it to that point, are we talking about up to the point at which built-in Kubernetes APIs will handle that, or are you including like custom CRDs and other things that might do their own resource manipulation in cluster? Like
Right.
where's the end of that rendered manifest versus?
Yeah, and you can put custom resources into ConfigHub as well. If it is generating other resources, it would have to fully control those resources, right? Because those, you wouldn't put those in Git either, right? So it's like the deployment creates replica sets, creates pods. The pods don't go in the desired state. So you can do that. It limits how much you can customize those resources statically. You could build a controller to do it, but there's a trade-off. No. Correct. Yeah, we can follow up.
We're out of time.
Okay.